So here's what's been happening. While everyone's been arguing about ChatGPT writing essays and AI art controversies, artificial intelligence just quietly solved problems that stumped humanity for half a century. We're talking about breakthroughs that took scientists decades to achieve, now happening in hours. Diseases that seemed incurable, suddenly showing pathways to treatment. Mathematical problems that only Olympic level geniuses could solve, now cracked by algorithms in seconds. Most people think AI is just for chatbots and image generators, and for a while, that's all anyone talked about. ChatGPT this, DALL-E that, Midjourney drama, but behind the scenes, something far more profound has been unfolding. AI hasn't just been making art or answering questions, it's been reshaping the entire foundation of scientific discovery itself. Yeah, that's the level of transformation we're talking about. The protein folding revolution. Right away, let's talk about the breakthrough that changed everything. For 50 years, 5 full decades, predicting how proteins fold was biology's Mount Everest. Impossible, unsolvable, the kind of problem that ended careers and consumed entire research budgets. And here's why it mattered. Proteins are literally the machinery of life. Your body runs on proteins. They determine how cells function, how diseases spread, how your immune system fights back. The problem was simple but brutal. A protein's shape determines everything about how it works. Get the shape wrong, and you get Alzheimer's, Parkinson's, cancer, countless diseases that we couldn't understand because we couldn't predict how these molecular machines actually folded into their final forms. Traditional methods required years of painstaking lab experiments, X-ray crystallography, nuclear magnetic resonance, cryo-electron microscopy. Each structure took researchers months or years to solve. Then in 2020, DeepMind dropped AlphaFold, and everything changed. This AI system could accurately predict protein structures in hours, not years, hours, with accuracy that matched experimental results. Scientists couldn't believe it. The biological community literally called it a once-in-a-generation breakthrough. But that wasn't the full story. By 2022, AlphaFold had mapped over 200 million proteins. Let that sink in. 200 million. That's nearly every known protein on Earth, solved and cataloged. Problems that would have taken humanity centuries to work through. Finished in 2 years. Researchers immediately started using these predictions to advance treatments for diseases, design new enzymes for industry, and explore ways to tackle antibiotic resistance. And here's the kicker. This wasn't just about speed. AlphaFold revealed protein structures that nobody had ever seen before, opening up entirely new avenues for drug development and understanding how life works at the molecular level. The impact is still rippling through biology, medicine, and pharmaceutical research. This single AI breakthrough probably advanced biological science by decades. Mind reading becomes reality. The weird part is, protein folding was just the beginning. While that was happening, another team of researchers was working on something that sounds like pure science fiction, reading thoughts directly from brain activity and turning them into text. Not slowly, not with weird helmet contraptions. We're talking nearly 80 words per minute. In 2023, Stanford researchers used AI to decode brain signals into readable text for paralyzed patients who couldn't speak or move. One patient literally said, "I can talk to you with my thoughts," and she wasn't exaggerating. Deep learning models trained on brain activity patterns learn to translate neural signals into coherent sentences. At UC San Francisco, another team achieved similar results, giving people who had lost the ability to speak a voice again. But it wasn't just about communication. Patients started controlling robotic arms through thought alone. Typing on digital keyboards just by thinking about letters, moving cursors on screens without lifting a finger. Brain-computer interfaces went from theoretical research to practical medical devices in just a few years. And AI was the bridge that made it possible, learning the incredibly complex patterns of how thoughts translate into neural activity. Clinical trials are now testing wireless systems that could replace bulky implants. The technology is getting more accurate, less invasive, and closer to becoming mainstream medical treatment. We're watching the early stages of technology that could fundamentally change how humans interact with machines and restore lost capabilities to people with paralysis or neurological conditions. AI becomes a mathematical genius, so that's medicine and neuroscience. But here's where it gets really interesting. AI started competing with the world's best mathematicians and winning. DeepMind's Alpha Geometry, introduced in 2024, solved 83% of International Mathematical Olympiad geometry problems spanning 25 years. That's performance comparable to gold medalists, the absolute best young mathematicians on the planet. These aren't simple algebra problems. We're talking about advanced geometric proofs that require deep reasoning, creativity, and mathematical intuition. What makes this breakthrough unique is transparency. Previous AI systems were black boxes. They'd spit out answers, but nobody understood how they got there. Alpha Geometry shows its work step by step, just like a human mathematician would. You can follow the logical progression, see the reasoning, understand the proof. The implications go far beyond math competitions, though. Geometry underpins robotics navigation systems, computer graphics and 3D modeling, physics simulations, architectural design. With AI capable of proving theorems at Olympic level, scientists are optimistic about fresh insights in pure mathematics that could unlock more reliable algorithms for engineering and science. And that's just geometry. Other AI systems are now tackling algebra, calculus, and abstract mathematical concepts. The boundary between human mathematical reasoning and AI capabilities is blurring fast. Some mathematicians are excited about AI as a collaboration tool. Others are worried about what happens when machines can prove theorems humans can't even understand. Weather prediction gets supernatural. All of this happened while another revolution was brewing, weather forecasting. And before you roll your eyes thinking, who cares about weather apps? Understand this. Accurate forecasts save lives. Knowing about a hurricane 5 days versus 5 hours in advance is the difference between organized evacuation and catastrophic casualties. Traditional weather models take hours of supercomputer processing time. Teams of meteorologists feeding atmospheric data into physics-based simulations, waiting for results, adjusting parameters. It's expensive, slow, and still gets things wrong regularly. Then, in 2023, DeepMind's GraphCast upended the entire field. This AI system produced weather forecasts in seconds, not hours, seconds, while outperforming Europe's ECMWF on 90% of key metrics. The ECMWF is the world's leading physics-based weather model, representing decades of meteorological research and billions in supercomputing infrastructure. And an AI trained on historical weather data beat it. GraphCast successfully predicted Cyclone Mocha, which devastated Myanmar in May 2023, nearly a week in advance. That extra warning time allowed evacuation efforts that saved thousands of lives. Weather agencies worldwide are now scrambling to integrate AI models alongside their existing systems. With climate change driving more extreme weather, bigger hurricanes, unprecedented floods, record-breaking heat waves, faster and more accurate predictions aren't just convenient, they're essential. Communities need time to prepare. Emergency services need time to mobilize. And I just gave them that time. The material science time machine. But it wasn't just weather and math. Material science just leapt centuries ahead in a single announcement. In 2023, Google DeepMind unveiled GNOME, an AI tool that predicted the stability of millions of crystal structures. And when I say millions, I mean it analyzed possibilities that would have taken human researchers almost 800 years to discover at the normal lab pace. Out of these millions of simulations, GNOME identified 380,000 previously unknown stable materials, 380,000 materials that could revolutionize batteries, making electric vehicles more practical, solar panels that could be more efficient and cheaper to produce, superconductors that could transform power transmission and quantum computing. Early lab tests have already confirmed several of these predictions, which means this isn't theoretical. These are real materials that actually exist and can be synthesized. The AI didn't just guess randomly. It understood the underlying physics and chemistry well enough to predict which atomic arrangements would be stable. This AI-driven roadmap is transforming how scientists search for the building blocks of future technologies. Instead of random trial and error, mixing compounds, testing properties, hoping something works, researchers now know exactly where to look. It's like having a map to buried treasure instead of digging holes randomly across an entire continent. AI inventing better AI. And here's where things get meta. AI isn't only solving problems anymore, it's creating new solutions that make computing itself more efficient. In 2023, DeepMind's AlphaDev discovered a faster sorting algorithm that was later adopted into the official C++ standard library. Read that again. I created an algorithm that became part of the fundamental tools human programmers use every single day. This wasn't some obscure optimization for a niche application. Sorting algorithms are used billions of times per second across every computer, phone, and server on the planet. Making them even fractionally faster saves enormous amounts of energy and computing resources globally, but that was just the beginning. In 2025, AlphaEvolve took it further by designing state-of-the-art algorithms across 50 open math and optimization problems, beating human-devised methods in most cases. For the first time in computing history, AI is directly contributing to the foundation of computer science itself. The tools we use to build software are now being improved by the very AI that runs on that software. Some computer scientists find this exciting. AI as a collaborator that can explore optimization spaces humans would never think to check. Others find it unsettling. If AI can improve the algorithms that run AI, we're entering a feedback loop where machine intelligence accelerates its own development. The robot scientists. This all snowballed fast because AI wasn't just making predictions, it was running actual physical experiments. In 2023, researchers at the University of Liverpool demonstrated an autonomous robot scientist that ran experiments around the clock, testing hypotheses, analyzing results, and deciding its next steps without human input. Think about how traditional science works. Researchers come in at 9 a.m., run experiments all day, go home at 6 p.m., labs sit empty overnight. Weekends, holidays, no work getting done. That robot scientist never sleeps, never takes breaks, operates 24/7, continuously running experiments, learning from results, designing better tests. Unlike traditional labs that shut down overnight, these systems can operate continuously, accelerating discovery cycles. Similar platforms are being tested for chemistry and biology, where trial and error dominates research. By integrating robotics with AI decision-making, researchers can cover far more ground in weeks than human teams could manage in years. The implications are massive. Drug discovery could happen exponentially faster. Materials testing could iterate through thousands of combinations. Chemistry experiments that used to take months could finish in days. We're not replacing human scientists. We're giving them tireless robot assistants that can handle the tedious, repetitive work while humans focus on creative insights and experimental design. Medical imaging revolution. And that's exactly what's happening in hospitals right now. Medical imaging has exploded in volume. Millions of CT scans, MRIs, and X-rays performed daily. Radiologists face overwhelming workloads, and mistakes happen when humans are exhausted and rushed. This is where AI foundation models are stepping in. In 2023, Google's MedPalm-M was tested for analyzing chest X-rays, showing diagnostic accuracy on par with expert radiologists. Meanwhile, the NHS in the UK has begun piloting AI systems to triage scans and flag urgent cases faster. A patient with a suspected stroke gets their scan reviewed by AI within minutes. Alerts sent to specialists immediately. Treatment started sooner. Instead of replacing doctors, these tools act as co-pilots, helping spot early signs of cancers or fractures that might otherwise be missed under heavy pressure. The AI never gets tired, never loses focus, never has a bad day. It's consistent, fast, and increasingly accurate. The reason radiology has advanced so quickly with AI is simple. It's driven by data, and radiology has massive amounts of digital data ready to be used. Millions of labeled scans showing what cancer looks like, what healthy tissue looks like, what fractures look like. AI trained on this data becomes an expert diagnostic assistant. Spatial intelligence. And there's one more frontier that's quietly transforming: spatial intelligence. AI isn't only about text or images anymore. It's learning to understand the real world in 3 dimensions. Large geospatial models and visual positioning systems now provide centimeter-level mapping accuracy. In 2024, companies like Niantic and Google demonstrated how AI can anchor digital content precisely in physical space. Augmented reality apps that know exactly where you are, what you're looking at, and how to overlay digital information on the real world. Robotics labs applied similar models to improve navigation for autonomous machines. This shift matters for self-driving cars. AI that understands not just what objects are in a scene, but their exact positions, how they're moving, where they'll be in the next second. It matters for augmented reality, digital overlays that stay perfectly locked to real-world locations. It matters for supply chain logistics, robots that can navigate warehouses and understand three-dimensional space like humans do. By giving AI a better grasp of physical environments, researchers are bridging the digital and physical worlds in ways that directly affect daily life. So here's where we are. From folding proteins to decoding brains, from predicting storms to inventing algorithms, from mapping neurons to detecting gravitational waves. AI is no longer just assisting research, it's becoming a discovery engine of its own. These breakthroughs show how AI is quietly transforming science at every level. Problems that stumped humanity for decades are falling in months. Discoveries that would have taken centuries are happening in years. The pace isn't just accelerating, it's becoming exponential. And there's a bigger implication here, one that nobody's fully grappling with yet. When AI can make scientific discoveries faster than humans can comprehend them, when machines can prove theorems we can't understand, when algorithms design better algorithms in feedback loops we can't control, what does that mean for human scientific progress? Are we becoming partners with AI in discovery, or observers watching machines unlock the universe's secrets without us? The question isn't whether AI will transform science, it already has. The question is whether humans will remain the primary drivers of scientific progress, or whether we're transitioning to a new model where AI leads and humans follow. From molecules to galaxies, the story of AI and science is only just beginning. And what happens next will define not just technology, but humanity's relationship with knowledge itself. If you made it this far, let us know which AI discovery shocked you the most in the comments below. For more analysis on how AI is reshaping our world, make sure you check out our recommended video on the screen right now. Thanks for watching.